The future of Tornado Alley is rapidly evolving, with growing evidence that tornadoes are shifting eastward into more densely populated areas. Historically, Tornado Alley referred to the Central Plains, including Texas, Oklahoma, Kansas, and Nebraska, known for frequent severe tornado outbreaks. However, climate data and storm analysis reveal that the highest frequency of significant tornadoes is steadily moving eastward. States like Arkansas, Tennessee, Mississippi, Alabama, and parts of Kentucky are experiencing more frequent and intense tornado events. This shift is alarming because these eastern states have higher population densities, more mobile homes, and fewer storm shelters. Unlike the relatively flat, open terrain of the Great Plains, the Southeast's hills, forests, and cities complicate tornado detection and evacuation. Scientists attribute the eastward shift to several climate and atmospheric changes linked to rising global temperatures. Warming air holds more moisture, fueling stronger thunderstorms capable of producing long-track, high-intensity tornadoes. Warmer Gulf of Mexico waters feed more humid air into the southeastern U.S., creating ideal conditions for severe storms. Increased atmospheric instability, combined with changing jet stream patterns, shifts tornado formation into the Mississippi River Valley region. The southeast tornado season has grown longer, with outbreaks occurring earlier in spring and extending into late fall. More tornadoes now strike outside traditional peak months, catching communities off guard and reducing seasonal preparedness. Nighttime tornadoes, particularly deadly due to reduced visibility, are also more common in the southeast's expanding Tornado Alley. The region's higher humidity levels and slower temperature drops after sunset help storms maintain intensity after dark. This growing nocturnal tornado risk increases fatalities, as people sleep through warnings or lack access to storm shelters. The eastward shift is partly driven by the jet stream's changing position due to warming in the Arctic and tropics. The jet stream, which guides storm systems, has become more erratic, sometimes dipping farther south into the southeast. This altered storm track directs more severe weather into areas historically less prepared for large tornado outbreaks. Urban sprawl in the southeast further increases tornado risk, placing more homes and infrastructure directly in harm's way. The region's growing population expands into rural areas, where mobile homes and older structures offer little tornado protection. Research shows that tornadoes in the eastern U.S. tend to occur in larger clusters, producing multi-state outbreaks with higher death tolls. Climate change doesn't directly cause tornadoes, but it enhances the atmospheric ingredients necessary for severe storm formation. Warmer air, more moisture, and stronger instability all increase the potential for supercell development, the primary tornado producers. Supercells, which feature powerful rotating updrafts, thrive in the increasingly volatile atmospheric environment across the southeast. Studies also indicate that tornado outbreaks in the eastern U.S. are producing more violent, long-track tornadoes than in past decades. Long-track tornadoes remain on the ground for tens of miles, cutting wider swaths of destruction through communities. The increased frequency of EF3, EF4, and EF5 tornadoes highlights how severe weather is intensifying as climate patterns shift. Population vulnerability is higher in the southeast, where many homes lack basements or reinforced storm shelters. This structural vulnerability, combined with increased tornado frequency, creates a perfect storm for higher casualty rates. Emergency management officials stress that traditional tornado alley preparedness strategies must expand to cover the southeast. Schools, hospitals, and mobile home communities in newly affected areas must adopt tornado drills and improve warning systems. The National Weather Service is adapting its forecasting techniques to better predict tornado risk in shifting hotspot areas. Doppler radar advancements and machine learning help meteorologists detect rotation earlier, but detection is harder in forested terrain. The southeast's hilly topography reduces visibility for storm spotters, making real-time tornado confirmation more challenging. This terrain challenge increases reliance on radar, satellite data, and mobile warnings to alert residents in threatened areas. Scientists are also studying how land surface changes, like urbanization and deforestation, affect local storm formation. Urban heat islands, which create localized warming, may enhance instability and trigger storms capable of spawning tornadoes. Deforestation removes natural wind breaks, potentially altering local wind shear patterns that influence tornado development. Some researchers suspect that climate-driven shifts in the dry line, which separates moist and dry air masses, play a role. The dry line, traditionally positioned across the plains, may be migrating eastward, pushing severe weather zones with it. This eastward migration exposes states like Missouri, Arkansas, and Tennessee to more frequent clashes between air masses. These states also lie within the Dixie Alley region, historically a secondary tornado hotspot, which is becoming more active. Dixie Alley tornadoes tend to occur in complex storm systems that produce heavy rain, flooding, and embedded tornadoes. Rain-wrapped tornadoes, common in the southeast, are harder to see and increase the risk of late evacuation or missed warnings. Because tornadoes in the eastern U.S. occur in wetter, more humid environments, they are often part of multi-hazard storms. These storms frequently produce damaging winds, large hail, flash floods, and lightning alongside tornadoes, compounding the danger. Tornado fatality rates in the southeast are consistently higher than in traditional tornado alley, largely due to population density. Increased tornado frequency in urban corridors from Nashville to Atlanta heightens the potential for catastrophic mass casualty events. Infrastructure resilience is also lower in parts of the southeast, where older homes and aging utilities increase vulnerability. Tornado outbreaks striking densely populated regions can disrupt power, communication, and emergency response for days. The combination of higher tornado frequency, increased storm intensity, and growing population exposure raises national concern. Insurance claims for tornado damage are rising fastest in the southeast, signaling both increased risk and higher reconstruction costs. Scientists emphasize that the eastward shift is not temporary, it reflects long-term climate and atmospheric changes underway. As global temperatures continue rising, Tornado Alley will likely stretch farther east, encompassing more states and urban centers. Communities once considered outside tornado danger zones must adapt to this new reality of shifting severe weather risk. Improved building codes, community shelters, and early warning systems can reduce casualties, but awareness must spread quickly. Public education campaigns stressing tornado safety in newly vulnerable states are critical to saving lives in future outbreaks. Tornado researchers stress that future climate models must better incorporate severe convective storm processes to refine risk forecasts. Most current climate models excel at predicting temperature and precipitation but struggle to capture tornado dynamics directly. Enhanced high-resolution modeling capable of simulating supercell development could help communities prepare for future tornado seasons. The story of Tornado Alley's future is no longer confined to the Great Plains, it stretches into forests, hills, and cities of the East. Adapting to this new reality will require blending climate science, meteorology, urban planning, and emergency management into one coordinated strategy. The next generation of Tornado Alley residents may live not on the open plains, but in suburbs, river valleys, and forests across the southeast. Wherever it shifts, Tornado Alley serves as a reminder that climate change doesn't just alter weather, it reshapes the entire map of risk and resilience.